Welcome to the Battery Innovation Center, Newberry, Indiana. This is the Energy Storage Short Course.
The Battery Innovation Center Short Course is the way that we teach people about the battery industry from start to finish. Now, your graphite is your anode active material. Your NMC is your cathode active material.
Every battery will have an electrolyte. There's no such thing as an electrolyte-free battery.
Material processing, cell manufacturing.
You can get a lot of cracking on the top surface of your battery if you're overutilizing that area, and then the depth of your electrode actually will have fairly pristine active material.
That's not going anywhere, and this is almost entirely liquid. And it'll just hold that shape. It'll even hold its shape through the drying process. As you can see, we have dried electrode. That's a good thing, because if it's wet here, we have a big problem. So you can see now that this material is a lot shinier than it was before it went through. But you can also see kind of spots and maybe streaks.
Cell construction, cell testing, safety, showing us the lab, showing us where they create cells, the dry room.
We're doing a lot of desiccation and air purification in here. Reactivity goes up as you go down the periodic table. Raw lithium metal.
We're going to start with coin cell formats always if you're trying to understand a material or characterize a material.
We keep learning, we bring in experts, we do research and development.
Pack design, thermal management systems, battery management systems.
What is a BMS? Battery monitoring system and a battery management system. What we're talking about here is a battery management system.
So this one would be active balancing with these transformers. Put your leads here. It could measure this one, or it could measure around this way.
We're moving away from so many precious metals in batteries and moving toward critical metals. We like to use end of first life rather than terms like battery recycling.
How can we take cells that we're making, packs that we're making, use them for grid storage, really try to fill in that circular economy to make sure that all the cells that we're producing now have a full life cycle and all the way to a recycling cycle.
There's still research and development going on these. We've had projects using new plate technology.
Right now, I'm about to go through standards, probably the most exciting lecture of all day. Standards bodies that do things like this are people like UL or Under Eyes Laboratory, who is an incubator here at the Battery Innovation Center.
Destructive testing and life cycle testing.
This is just the first cycle of putting a cell on test, and even before we start looking at this chart, looking at this data, there's some helpful information that we can gather from putting this cell on test. And that is just looking at the OCV, open circuit voltage.
If we want to test for like UN383, we would use this chamber.
So right here, you're looking at a nail penetration on a prismatic cell. You can see there's a lot of flames going out. It looks almost like jets of flames, and in real life, that is exactly what it looks like.
If you have thermal runaway in one cell, how does that progress to the rest of the battery? You're probably not going to stop it, but it looks like this.